Now, this is where we stopped in the previous class. So here, a man wants to check the inventory. A man wants to check the inventory records against the physical inventories. Okay, so he is supposed to check the inventory record against physical inventory. Now, what they are trying to do is they will have a record of the stock in the book, as well as the same products will be physically present in the godown or warehouse. Okay, so that is the inventory records they check. So once they can check the inventory records in the books, and they also have to check the physical goods once again to make sure everything is same. And they've told that there is a sample survey which has been done, and in that sample survey there can be a difference of plus or minus 5 that can happen. Now let us take for example, we are counting the number of soap bars that is present in the warehouse. Now, what are these soap bars? Soap bars, if it is present in the warehouse will have the racks where they would have stored boxes of soap bars. Correct? So, when we go and check the stock, physical stock, we will not open every box and check the stock. So, what we will do in this one row, if I open one box, I will see how many soaps are there in that one box. Suppose if there are 50 soaps in one box, then I will count the number of boxes that are present. So suppose if there are 10 boxes which are present, so the stock in the first row is going to become 50 soaps into 10 boxes. That is nothing but 500 soaps, right? Now I can have a plus or minus 5. If I am getting somewhere 496, 495, if I am getting the numbers like this, or if I am getting 502, 504, if I am getting numbers like this, that is plus or minus 5, which can be the difference. In one row there can be a minus 5, in the other row there can be a plus 5. That will help us to get the total count. So here they are okay with the plus 5 and minus 5. That is the difference that they get while doing the checking of the samples. Now they have asked us, or they have actually given us first the standard deviation. And then they have asked us to find the sample size if the confidence level is 90%, where the z value is given to us, that is confidence coefficient, that is 1.64. So 1.64 is the confidence coefficient, that is nothing but the z value. So z value here is 1.64, and standard deviation which is given to us is 19.7, and the deviation that we can take, okay, the deviation, the difference that can be there is plus 5 or minus 5. So that will be the margin of error. So I am just taking it as plus 5 here, or the number 5. Instead of taking plus or minus, I'm just taking the number 5. So the formula for sample size with standard deviation will be n into standard deviation into z into standard deviation by e whole square. So n into 1.64 into 19.7 divided by 5 whole square. If you solve this, you get a sample size of 42. So if they check 42 number of products, if they check 42 number of products, that would be enough for them to analyze the whole stock. So that is why we are calculating the sample size. Understood this problem? Can we go to the next problem? Anybody has doubts here still? Okay, good. So Akila understood the problem. Any doubts there? You are the one who asked to explain it again. Okay, good. Now moving on to the next problem. If the population standard deviation is 150, what should be the sample size to estimate population mean with allowable error? Underline this part specially. Allowable error 10. Allowable error is 10 at 90% confidence level and 95% confidence level. So at 90% confidence level, what will be the sample size? And at 95% confident level, what will be the sample size is what they are asking. And they have given us the standard deviation. So if you read the first line of the problem, the population standard deviation is given to us, which is nothing but mu. So at the end of the day, they have given us standard deviation, and they have asked that what should be the sample size so that the mean of the population, okay, at what level of the sample size the mean of the population will have some difference up to 10, and at 90% confidence level and 95% confidence level. All that you have to see in the question is just have they given you standard deviation or have they given you population proportion. So in this problem they have given you standard deviation, and if you see note given there, at 90% value the confidence coefficient, that is Z, is equal to 1.64, and at 95% the Z value is 1.96. Okay, so that is the value. So first we have to solve 90% confidence level sample size separately and 95% confidence level sample size separately. So if you see here, Z is equal to 1.64, that is at 90% we are solving it, and the standard deviation will remain same, that is 150. And then what is that we require? The margin of error, and it clearly says allowable error. Okay, this is the limit. Allowable error is 10. So E will be is equal to 10. And the sample size, to find out sample size, what is the formula? N into Z multiplied with, N is equal to Z into standard deviation by margin of error whole square. So we know what is Z, we know what is standard deviation, and then coming to the margin of error. So once we apply all this and we calculate, the sample size at 90% confidence level is going to be 605.16. Okay, that is the sample size at 90% confident level. So at 90% confidence, they are 90% confident that if you take 605 people, okay, if you take 605 people, the mean of it will be plus or minus 10. That is the sample size estimation we are trying to do. Did you all understand the first part of the question, that is 90% confidence level? Yes. Okay. Now, that was 90% confident. Now, similarly, we have to find out 95% confident. It is something like this. We are, you know, let's say we are doing some, we are preparing some dish. Now, we will first have some ingredients in mind, right? Okay. Now, let's take a simple dish what we are trying to prepare. Let's say we are preparing chitrana. Easy, very easy to do. Now, for that lemon rice that we do, we are supposed to have the proportion of oil, spices, then the lemon juice, a little grated coconut. All this we will put, right? So, before even preparing the lemon rice, we will have some, quantity in mind. Okay, it has to be for 4 people, it has to be for 5 people, or it has to be for two of them. So like this we will have the quantity in mind. Based on that quantity only, we will be able to do the prepare the lemon rice. Correct. Now, if they are experienced people at home, if they are people who have been cooking for quite a long time, they will easily know how much quantity we have to put for every ingredient. But if you're a new person who are trying to cook, then you will have to do some experimentation, right? Now, in this stage also, we are technically finding out what should be the quantity of the ingredient so that we get the best taste. Okay. If the sample size of the chilies that you add to the lemon rice, if it is 3, you are 90% confident that the taste will be correct. Okay. If it is 4, you are 95% confident that it will be too spicy. Are you able to relate? I am trying to make it as easy as possible. So here we are again getting the proportion of the ingredients, so that we will be able to estimate, we will be able to understand how much is the spiciness level that has to be carried in the food. Did you understand the example? Okay. Now let us apply the same example into the problem here. Now here in this problem, they are saying that there is a population. There are number of people, okay, where we have to say them at how many number of people if I take them separately. Okay, the value of the mean is nothing but the spiciness that one can eat. Okay, I can eat spiciness up to, let's say, 3 chilies. So that is the level of spiciness. So what is the population mean, until what it can be allowed, what it can be accepted? So if my sample size is 605, as per this problem, if the sample size is 605 people, I am 90% confident that the error in the population mean will be less than 10. Okay, so that is for the 90% confidence level. Now 95, similarly we will find out 95% confidence level. Now the more number of people you try to get the data, the more accurate the data will be. Now if I take if I only ask 2 of you to submit the notes or submit the assignment, you only 2 of you would have submitted the assignment. Okay, but how about others? How will I know that the others have submitted the assignment or not? The more number of people I ask to submit the assignment, the more accurate data I will get, stating that okay, all of them have submitted. All of them have returned. They have completed the assignment. Okay. So at 95% level, again, the Z value will change. So if you see here at 95%, the Z value is 1.96. So at 95% level, once it changes, then they will have the standard deviation will remain same. The margin of error will also remain same. So you have Z into standard deviation divided by margin of error whole square. And then if you see here, the more sample size you take, the more confident you are about the data. Okay, so the sample size is going to be 864 for 95% and 605 for 90% confidence level. So that is the data that you will be seeing here. Understood this problem? Any doubts in this problem? Okay, good. Now let us go to the next problem. Now the next problem, listen carefully. The manufacturer of TV wants to estimate the proportion of people. See, you have the word proportion. Okay, first thing, proportion of people in a given income bracket who are interested in the model. So let's read the first line once again. The manufacturer of TV wants to estimate the proportion of people. Okay, the owner of the TV company wants to understand some data about the people. So what is that? He wants to know the proportion of people in the income bracket. Now let's take for example, if a person is earning 10,000 rupees per month. Okay, so this is for 1 month. So for 1 year, how much will he have? 10,000 into 12. So he will have 1,20,000. Correct? So income bracket of people who are earning 1,20,000. Suppose if the person is earning 20,000 for 1 year into 12, he will have 2,40,000 as the income bracket. So in a certain income bracket, they wanted to know who are interested to buy the TV. Then the company wants to know the population proportion. So what are we supposed to find? We are supposed to find the population proportion P to be within 0.1. So this population P should be within 0.1. So they have given us the value of P directly. So the company wants us to understand that the proportion should be within the 0.1. So that is P is equal to 0.1 with 99% confidence levels. And they have given us the Z value. Now current company records indicate that P may be around 0.25. So current company records, according to the books, it says that P may be around 0.25. Around, so it's not sure, it's just around. So this 0.25, I will take this as margin of error, so that there can be a difference in the number up to 0.25. So what is the minimum required sample size for his survey? So we have to understand how much is the sample size that is required. So did you all understand the question first of all? That the TV company owner wants to understand at what income bracket people are interested to buy the TV. Okay, if at all they get 3,000 rupees as salary every month, as their income every month, they will not, that 3,000 will not be enough for them to take care of themselves. From where will they buy the TV, fridge and all that, right? So at what income price, or what should be the income bracket where they'll be able to buy the TV? That is what the owner wants to know. Okay, so that he's thinking of doing a survey. He's thinking of doing a survey. Now for the survey, we have to say him how many people he should ask the questions, so that he will get the data. That how many people to ask the questions, we have to find the answer using the formula. Now here they have given us population proportion and not standard deviation. So when the population proportion is given, the formula will be different. That is n is equal to z square into p into 1 minus p divided by e square. So z square is 2.58 square, that is already given to us in the question. And then p is 0.1, because if you see here, population proportion is p, which is within 0.1. Okay, so this 0.1 has to be considered for p, and e square is 0.25. Okay, and if you find out the value here, the sample size will be 9.58, which is nothing but 10. So if the TV company owner is taking the survey of 10 people, he will be able to understand which income bracket the people are interested to buy the TV. If are people with more income interested to buy the TV model, or the people with very less income, are they also interested? So he will be able to understand that. Now is it clear? Did you all understand this problem? Okay. Now moving on to the next question. Research sets 95%. Okay, this is a different question. They have told it has come in June 2015. So let us see. Research sets 95%, that is Z is 1.96 confidence level. A precision is the error. Okay, so here let us see what is there. Precision is 5%, that is 0.05. So this is the error. See, they have directly given you all the information. And proportion is P, that is 50%. So this is another type of problem that they may ask. It's still doubtful, they may ask. So when they're doing research, they have set the confidence level at 95%, where the Z value at 95% will be 1.96, and they have kept a precision, that is the error of margin. See, they have given you E here. Okay, so error of margin is 5%. So 5%, that is nothing but 5 by 100. So 0.05. So this is the error of margin, and proportion P is 50%. So P is again 50%, which is 50 by 100. Again, what do you get? 0.5. Okay, so Z is 1.96, E is 0.05, and P is 0.5. So that is the value, and N is equal to Z square P into 1 minus P by E square. So 1.96 square into 0.5 into 1 minus 0.5 by 0.05 square. Whatever data we have here, we are applying it. So once you do the simplification, the sample size that is required will be 384. So if you have 384 as the sample size, then we will be able to get the proportion of 50%. Error can be 5%, and we will be 95% confident about the result. So this is another type of problem where they give you direct data without any much statements. Understood this? Did you all understand this problem? It's much of self-explanatory actually. Can we go to the next question? Now the next question. It is known that the population standard deviation in waiting time for a new gas connection in a particular town is 25 days. Okay, now let's take for example Bangalore only. Now Bangalore, we require a new gas connection, that is the cooking gas suppose, and we are waiting, we have to wait for 25 days to get the connection. Okay, how large a sample could be chosen with an allowable error of 6 days of the true average waiting time at 95% confidence interval. So what they are saying, suppose in Bangalore, if today we book for the gas, now today what is the date? 14th December. Now on 14th December, if we go and register for the new connection, okay, now after 25 days only we will get the connection. Okay, so after 25 days from 14 means at what date you might get? Somewhere around the 7th January 2021. So if I take today's date on which I have registered and I have told that I require the cooking gas. Okay. Now I have to wait for 25 days. This is the waiting time. And I may get the gas connection on 7th. Now, let's say there was some problem. There was some situation where there can be extra 6 days added to this. Okay, extra 6 days means 7 plus 6 is 13. So I can either get the gas connection on 7th January or I can get the gas connection on 13th January. Okay, I can get the connection on 13th January. So this 6 can be plus or minus 6. So I have 3 dates in hand. What are the 3 dates? I can get minus 6. 7 minus 6 is 1. I can either get the gas connection on 1st January or I can get it on 7th January or I can get it on 13th January. Okay, so that is the waiting time. So what they are asking us is how large a sample could be chosen for available error of 6 days that is allowed. So I have to create a sample so that plus or minus 6 can be calculated on that, and at 95% of interval, confidence interval, and the Z value for the same is 1.96. So what all do I have? Blindly you just have to find out what all information you have. So the first information that you have is Z, which is 1.96, and the standard deviation. If you see here, the population standard deviation is 25. 25 days is given, right? So that is 25. And the margin of error, they can give me the gas connection after 6 days of 7th Jan or before 6 days of the 7th Jan. Okay, so the error that can happen early or late, that would be 6 days. So 6 should be the margin of error. Now once I got all the information, I'll just have to put that into the formula and simplify, where I will get the sample size to be 66. Okay, and when I round it off, that is 66.66, I get 67. So the sample size, which is 67, that should be the sample size wherein even if there is 6 days up and down, the gas connection will surely come. So this is the next problem. Any doubts in this problem? Did you all understand? The major thing which you'll have to learn in this chapter, see, problems are not much asked in every examination. Very rarely they have asked, but the theory question of types of you know, types of sampling distribution, definitions, those are very important for you to understand. These you just have to know two formulas, check whatever data is there in the question, and then solve it. Only if so much if you do, you will get the marks. No need to worry. Okay, understood? Can we go to the next problem? Okay, it is known that the population standard deviation is in waiting time. I think this is repetition. Seems like it's a repetition. Yeah, but a little change in the numbers. So I think you should be able to solve this. Okay, it's known that population standard deviation in waiting for the new gas connection is 25 days. Okay, however, how should be the sample if they are 95% confident and the average waiting days is within 6.125? There the error was 6. Now if you see here, the error was 6, and in this problem it is 6.125. Okay, and they have given us the Z value. So it is very similar problem, except that the error is being changed. See, once the error is being changed, the sample size will also change. Now in the previous question, the sample size was 67. Now here the sample size is 64. So this is of the same question. Now let us go to the last question of this chapter. Okay, a person wants to take survey of students to see how much homework they do in a week. Nice, no? Good question. Now they want to do a survey on how much homework the students will do in a week. Okay, he like to use 90% confidence interval if the population standard deviation is calculated as 4.5 hours. So what we are saying is the students will do the homework for 4.5 hours every week. So in 1 week, they're going to spend 4.5 hours in doing the homework. Then with the margin error, there can be some 0.75 hours that side and this side. So there can be a 45, let's take for example 45 minutes up and down. So how many students should be surveyed? So how many students should I ask about their homework timing? So that is what we are supposed to find out. So here we know the Z value, and it clearly says population standard deviation. So standard deviation is given 4.5 hours, and margin error directly it is mentioned. So E is equal to 0.75. Though it is plus or minus, just take the number 0.75. Okay, and then put that into the formula. N into Z into N is equal to Z into standard deviation by margin of error whole square, and you get the sample size, which is 138. So if you ask 138 students about their homework timing, then we will be able to understand what is the number of hours that the students spend on doing the homework. Okay, so this is your chapter of sampling and sampling distribution, wherein the theory plays a very major role. Please study all the theory and revise the problem. I'm not asking you to mug up the problems, that will not help you. Revise the problems, make sure you know both the definitions and both the formulas. The formulas are very important again. Clear? Any doubts until here? Please go through the classwork. If you have any doubt, do let me know. We'll be starting with the new chapter from the next class. No doubts? Okay, good. So we'll stop here for today and we'll continue in the next class. Okay, thank you, students.